I'm going to spend all that much time, so we'll see if it works for you guys. So, okay. All right, so just a little bit of background, real quick. We're starting chapter 7, and it's all about exponents. If I have x to the 5th power, which one of these is considered the base, the x or the 5? The x. This is the base, and this is how many. And you've been learning this since 6th grade, because I know for a fact when I had my 6th graders, we did the stupid clappy rappy thing, and it was really, I know it, yeah. Base, how many? Base, how many? Base, how many? And they started rapping and stomping and stuff, and it became a habit. But, you know, that's when you all were in 6th grade. So x is the base. The exponent tells you how many x's you would have to write down to multiply them all together. So suppose I had, I want to just show you something here, x to the 2nd times x to the 4th, just for fun, okay? Because, you know, it's fun. How many x's would I be talking about right here? 2. So I would have x times x creates x squared. How many x's would I be talking about here? 4. X, 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 x. This times this, how many total x's do I have here? And that's exactly how you would write it. Now, how did that happen? If you didn't write them all out right here, you wound up adding the exponents, and that's the bottom line, kind of where we're going today. If you have bases that are matching, you can add their exponents together to get the new answer, and that's with multiplication. But that's only when we're dealing with monomials. So that's where we need to kind of start. So a monomial is going to be a number. It can be a variable, or it can be the product. What does product mean? A multiplication problem, okay, that uses numbers and variables, and it could be more than one. It could be a whole bunch of stuff shoved together. The main thing is it represents one term. There's no plus signs or minus signs in between it as far as an adding or subtracting operation, okay? Now, that doesn't mean there won't be a negative, okay? For example, if I said negative 2x to the 3rd, y to the 4th, raised to the 3rd power, that's really a monomial. It has a bunch of junk added into it. There's a bunch of components. And there is a minus sign, but is it technically an adding or subtracting symbol? No, it's an identifying symbol. So notice there's no pluses or minuses, therefore this is a monomial, and everything's being added together. All right, now we're going to get started. So we talked about how you're actually going to do this. And you've noticed in your math books, they always use random letters and they try to show you without real numbers sometimes. Try to learn to understand that, because it can be helpful when you're doing assignments. And this is saying that you have for any number a and all integers m. So any number you want and any positive or non-negative integers would represent your exponent. Why did they say non-negative? What would be an example of the smallest possible integer that would be a non-negative? 1 is positive, 0 is non-negative. That's how they define 0, as being non-negative. Okay? So that's what they're talking about. So you can use integers and from 0 on up for your exponents, okay? I'm going to work the example that's in your notes, but I'm going to put it on a piece of notebook paper so it's bigger. I don't like all of the garbage that they've thrown into this, and you have this written down, so just kind of follow along with me here if you want to. Okay, step 1, we have a monomial times a monomial. This is a product. They're being multiplied together. I'm going to deal with my constants, which are my normal numbers out in front, or the coefficients. Okay, so my coefficients here are going to be a 3 and a 5. This is all multiplying, so this really does mean I'm going to have the number 3 and the number 5, and I'm going to multiply them together. What would I get? A 15. So I'm starting with my coefficients and I get a 15. Awesome. I took care of him and I took care of him. I'm now moving to the variables that are in the problem. I have a variable x. This x has an exponent of 6. This x has an exponent of 2. Don't I have matching bases? Then that means I'm going to add the exponents together. So my variables that have a base of x, here are the exponent 6 plus 2, which would make a 8, right? So 15x to the 8th power would be your final answer. Pretty easy? Yeah. All right, let's punch it up a little bit. We're going to multiply two monomials again, but this time we're going to have some negatives, and we're going to have more than one variable. This is the second example that's in your notes. Okay. What would you guess you should do first? Yeah, the 4 and the 3. The negative 4 times 3. What is a negative 4 times 3 going to create? Negative 12. Done. There we go. I took care of him. I took care of him. And you will notice that as I do these problems over the next week or so, I will be crossing them off once I've addressed them so I don't accidentally get confused and go back to them. So it might be something you might consider as a strategy for you. You don't have to. It's just, I'm just saying. All right. Alphabetically, we should start in order. All right, so the letter A comes first. I have an A, and that A has a power of 3, so I took care of that one. Do I have any more A values? Aha, right there. That A has a power of 2, so I can put a plus 2. I took care of that one. So far, so good? All right, let's go to the B. Oh. What, does it have an exponent? What you think? Perfect. Remember how we always say we assume there to be a 1 in front of a variable if you can't see it and you need it? We also assume there to be a 1 as an exponent on every number. That includes coefficients, everything, of 1. If you can't see it, you assume it has a 1. So I'm going to put a 1 right there so visually I won't forget about that. So this is really b to the first power, and this is b to the 5th power, so 1 plus 5. And so now I can clean it up and finish it. I get a negative 12, a to the 5, b to the 6th, and I finished my problem. Okay? So let's look at the triads. The first thing I would do always, I call it Oprahify it. You get a 1, you get a 1, you get a 1. You know how she gave everybody cars? We're going to give everybody 1s. We're not nearly as generous, okay? But, like if you look at problem number 1, see how that y does not have any exponent at all? You get a 1. Boom. So you don't forget about it, okay? Now do the math on it. You think Oprah would give me a trip out to her place if I said I was using her name in my math lessons? I'm Oprahifying a lesson? No? Dang it. I was hoping for a free vacation somewhere. All right, so we have y to the 1 and y to the 5th. That creates y to the 6th. That's it. Do I want to see this part? I do today. I won't be as grumpy about it tomorrow, but when you're first learning this lesson, it's important to do it right, okay? How about number 2? What should we do first there? Okay, multiply 4 and 5. And you get a 20. So I took care of those guys. And I have x to the 3. X to the 7, final answer, 20x to the 10. Any questions so far? Fairly easy? Okay. Don't freak out on the next one and don't cry and go, I don't know, I'm stuck, I don't know what to do. Pick up that calculator and put a fraction in it. You have a good calculator, use it if you need it. So we want our normal number 5 and the fraction 1/5. We need to multiply those two together, so put it in your calculator if you need to. What'd you get? 1. Good. All right, now let's see. Oh, you get a 1, you get a 1, you get a 1. There we go. So now I have the a. I have a to the second, and over here I have a to the 1. On the b values, I have b to the 1 plus b to the 1 again. Then the c values, c to the 3 and c to the 4. Final answer, a to the 3rd, b to the 2nd, c to the 7th. Did I have to have the 1 in front of it? No. Is it okay if you have the 1 in front of it? Absolutely, no problem. Okay? So far, so good? Any questions from anybody? You're so quiet, I feel like I'm by myself. We're good? Okay. All right. Here's where giving everybody a 1 is going to come in really important in this next section. This is going to you're going to have to really practice this, because the top part of the notes we had matching bases and we added their exponent. The bottom part of the notes we have a power to a power and we are going to multiply the exponents. And you might get those confused when you do each one, okay? So I'm going to try to help you. As usual, I have something stupid to say, and maybe you'll remember it, okay? So it says an expression in the form x to the mn is called a power of a power. I often call it a power to a power, okay? And so what you're going to do is multiply these two exponents together. And you can see here what it would look like if you had a to the m power, so some number raised to a power, and then that product of those guys was raised again. See how they have the m and the p side by side? Side by side means multiply, right? So what they really did was multiply these two exponents together. If you have more than one term, remember it's only a monomial, no pluses or minuses. If you have two terms that are now being raised, here's where the 1's come in handy. It's a now raised to the m power and b raised to the m power. You separate them and they each get the exponent. So the jingle goes like this. Power to a power stays in the